Today we're going to be talking about statistical significance and ruling out chance. Now, statistical significance is a statistical term used to determine when a treatment has actually been effective or not. So what we'll do is we'll have two groups. Many times one is a control group. Think about the dog food study that we looked at a couple days ago. And we gave some of the older dogs the new food, and we gave some of the older dogs the regular food, the old food. Now, we don't know if there's a difference between the groups, so what we do is we run statistical tests to determine if the statistics say there is a difference in the groups and that difference is caused by the treatment itself. So what I want you to do is, as we go through the notes today, I'm actually going to have you pause the video several times because there's a lot of reading, and I want you guys to read the contents rather than me reading it to you, and then try to answer some of the questions. So at this point, I want you to pause the video. I want you to read the recall section, the now section, and try the first example, example 1. So basically what I want you to do is do the entire first page by yourself. So go ahead and pause the video. Okay, so a couple of things I want you to notice about what you just read. When we look at doing an experiment, we tend to have the different groups will differ, and sometimes they differ just by chance. So if I'm asking or putting 10 people in one group and 10 people in another group, the group's outcomes might differ just because they're different people. But sometimes they're going to differ because of the treatment. So sometimes they're going to be very small differences, but sometimes they're going to be very large differences between the groups, and that's what we're going to focus on today. Now, statistically significant. Through simulation, we learn about whether these differences happen by chance or not. And we call the differences that don't happen by chance statistically significant differences. Again, those are ones that are not caused by chance. Not caused by chance. So the statistically significant meaning is the likelihood that a result or a relationship is caused by something other than random chance. So for example, the treatment. Now when we looked at the first example, they talked about putting tomatoes into different groups, and we're going to see if a certain nutrient applied to the tomatoes is going to help the tomatoes grow, and we're going to check their weight. So why is it important in this experiment for the 10 tomatoes to be all the same variety and grow under the same condition? Well, that's because we want to eliminate other variables from affecting the weight. We're trying to control the other variables, such as sunlight and soil type, because those kinds of things can have an effect on the weight of the tomato, and I want to see if it's the nutrients that have the effect. So you don't have to have my exact stuff written down, but you want to have something like that. You want to talk about controlling other variables. So what we're going to do in this lesson today is we're going to do an experiment with 10 different tomatoes, and in these cases, the 10 different tomatoes have been ordered from largest to smallest. And we're not going to be worried about which tomatoes got the nutrients right now. We're just going to assign them to two groups. So if we go to the next page, again, what I want you to do is I want you to read the first half up to interpreting the value of a difference, and I want you to calculate number 2 and number 3. So you're going to press pause, you're going to read through the first part of this the section, and then you're going to do 2 and 3. When you come back to the video, I'll have number 2 and 3 finished. Okay, so as you read, you found that we placed the tomatoes in two different groups, Group A and Group B, and you had to find the mean weight for both of the groups, which is the average weight in each group, and then the difference between their means. So you should have, what I did was I put Group A in L1 and Group B in L2, and I just ran one stat called one variable statistics to get the mean for each group. So I found that Group A had a mean of 6.76 ounces, and Group B had a mean of 6.4 ounces, so 4.8 ounces. Then I did the difference between the means. So the mean of A, Group A, minus the mean of Group B, and 6.78 minus 6.48, and I got 0.28 ounces. Okay. Now we're going to talk about, since we're looking at the difference, was there a difference in the groups, and is that difference significant or not? So again, what I want you to do is I want you to read through the second half of the page, and I want you to see if you can explain number 4 and number 5. So go ahead and press pause for the video, read through the next section, and tell me if you can answer, see if you can answer number 4 and number 5. Okay, so what you learned as you read through this section is we have something called what we call a diff score, which is the difference in the means. We found a mean for group A and a mean for group B, and we found the difference of those means. So in example 4, they want to know what a diff value of 1.64 ounces means when we're talking about the groups that we just looked at. So group A has a mean weight that is 1.64 ounces higher than the group B mean weight. For number 5, explain what a diff value of negative 0.4 ounces means. Well, because this one is negative 0.4, it means that the weight is actually lower for the first group than for the second group. Okay, so again, you should have something similar to that written down. You don't have to have it exactly, you can have it in your own words, but that's the idea that you want to get. 1.64 means group A is 1.64 ounces bigger than the weight of group B, the mean weight of group B, and negative 0.4 is 0.4 ounces lower than group B. Okay, so now what I want you to do is go over to number 6 on the next page and explain what a diff value of 0 ounces would mean. Well, if there's no difference as a diff score, that means the group A and group B have the same mean weight. There is no difference between the groups. Okay? So at this point, I want you to finish reading up this kind of recap on this section, and then go ahead and read about the distribution of diff and why diff is important. Then I'm going to come back to the video and I'm going to talk about the diff score before we start number 7 and 8. So go ahead and pause the video and just read up this next 2 sections. Okay, so just to recap the differences, what we looked at is we placed tomatoes in 2 different groups, we found the means of those groups, and then we looked at the differences of those means. Finding the differences are going to tell us, of course we're going to have, most of the time we're going to have differences because they're different groups of tomatoes, but are those differences going to be large, or are they going to be small? Are they going to be typical, or is it going to be unusual? And in order to get a sense of whether or not the treatment itself had an effect, we're going to have to look at the center, spread, and shape of the distribution if I were to run this repeated times. So I separated the tomatoes into 2 different groups, but I need to continuously do this to really get a sense of whether or not the treatment is going to be effective. And that's where the distribution of the diff score comes in. So I grouped A and B, I grouped the tomatoes into group A and group B, and I got the difference of the means. Now, what happens in this simulation is I'm going to do the same study 249 more times. So I'm going to place the tomatoes in group A and group B again, but I'm going to group different tomatoes in group A and group B. So maybe instead of putting tomato 1 and tomato 4 and tomato 5 into group A, maybe I'll do tomatoes 7, 8, 9, 10, and 2 in group A. So I'm going to put different tomatoes out of my study into group A and group B, get their means, and get their differences. I'm going to do this 250 times in total to create my dot plot. So I'm going to constantly put them into 2 different groups. I'm going to constantly get the mean of those groups. I'm going to constantly look at the difference of the means. And that's what I've just created was a random distribution for the diff scores, the difference in the means. That's what this distribution shows. So the distribution, it says the dots are placed at increments of 0.04 ounces. So every one of these values for these dots is going to be at 0.04 ounces. Now that I've just explained to you what this dot plot represents, again, we're taking those original tomatoes and we're regrouping them and regrouping them and regrouping them and regrouping them 250 times. And each time I regroup them, I find the average of their groups and I look at the difference in their averages, and that's what I'm plotting on the dot plot. So now what I want you to do is see if you can answer number 7 and number 8 based on the dot plot above. And go ahead and pause the video. Okay, now number 7, I wouldn't think you'd have too much of a problem with. You should have stated that the mean and the median appear to be close to 0. Maybe you might have said a little bit off from that because basically 0 is at the center of the data. Don't look at the number line. The center of the data seems to be around 0, maybe a little bit less than 0, you might have said, which is fine. Somewhere between 0 and negative 0.8. Now, number 8 would probably be a little bit harder for you. If I'm looking at 1.64 ounces or more, I'm looking right here. So what I'm going to do is I'm going to have to count all the dots that are in that area, 1.64 and higher. And what I count was 17 out of a total of 250 dots, which tells me that 6.8% of the results from my simulation, from mixing up those groups, end up with a difference of 1.64 or higher. Now, it would have been difficult for you to calculate B and C, but if I look at negative 0.8 or less, I would be looking here and smaller. So I'd have to count up all those dots, which ends up becoming 69 out of 250, because there's 250 dots altogether, which is 27.6. So that means that 27.6% of the time, I have differences between my two groups, means of negative 0.8 or less. And then finally, I wouldn't expect you to count 121 dots, but if I were between 0.8 and 0, which is in this section here, I ended up having to count 121 dots out of 250, which gives me 48.4%. Now, the reason I'm having you doing these probabilities is because the probabilities help me determine if the differences occurred by chance or not. So in other words, did the treatment have an effect, or was it just the chance that had that the weights were different? So now at this point, what I want you to do is I want you to go to the next page, and again, I'm going to have you read through this page here and see if you can answer questions 9, 10, 11 on your own. Make sure you pay attention to some of the important things in these bullet points here. So underline some key ideas that you might find, and then see if you can answer 9, 10, 11. When you come back, I'll have those done. Okay, hopefully what you picked out of this reading was, if the treatment was not effective, if the treatment that I applied, maybe the nutrients that I applied or the dog food that I used, if it wasn't affected, then I wouldn't see a difference between the means. There's no difference between the means, the treatment was not effective. And that makes sense, right? Now, the next thing I want you to pull out from that is that if the differences are extreme, far from 0, that means that it's not by chance, that it is statistically significant. So extreme values means statistically significant. It was the nutrient that had the effect. And then finally, the last bullet point, if the difference didn't just happen by chance alone, it was probably the treatment, in this case, the nutrient that we gave the tomatoes. Okay, so by definition, a diff value, when you look at a diff value of x, is statistically significant if there is a low probability that of obtaining the result that it is as extreme or more extreme than x. So if we look at 9, 10, 11, using the definition above, we've looked at 1.64 ounces. And 1.64 ounces had a low probability from the previous page. We got 6.8% for this diff score. Now, since that's a low probability means that I would have a statistically significant result. Okay, it's far from 0. And a low score of 6.8% means that there was a statistically significant result, meaning the treatment probably had an effect. For number 10, when I had a diff score of negative 0.8, that was a 27.6% chance, and 27.6% is not a very low probability. So because the probability is not low, it's not statistically significant. We need a low probability in order to be statistically significant. And then values within 0.8 and 0 ounces, we had 48.4% falling there, which means not statistically significant. 48.4% is not a small percent, so not statistically significant. Also, 0.8 is pretty close to 0, and if there's a diff score of 0, that means there's no change in the groups. So you go ahead and start your Chapter 12, Day 14 homework.